next to me here is Kevin Downey, who's the Global Chief Technologist at DXC. Lots of experience with their new Signal product. Second, we've got Quinn Lee, who's the Senior Vice President and Global Head of Qualcomm Ventures. And then we've got Sharon Mandell, who's the CIO for Juniper Networks. And so listen, we have an exciting conversation about this, like really digging into the business side of things, not just the speeds and feeds. And I think, Sharon, maybe if we can kick to you first, because you were the one who pointed out to us that this is really about the applications and the architecture, not so much about the technology.
Right. I mean, you know, we're all here to deliver business outcomes, and technology is here to enable them. So when we think about infrastructure, it's about how do you deliver the best customer experience, and for us, that means secure, not just up, but good, that it's easy to consume and quick to consume. So doing all the things up front to take heavy lifting that reduces time to value out of the equation. And so long before ChatGPT was the latest buzzword, Juniper's been using AI algorithms to change the ease with which you can deploy the network, the ease with which you can manage the network, to reduce tickets, to take the cost out of that infrastructure so you can apply your IT resources to something that's much more focused on the business outcome. Because at the end of the day, I obviously, given where I come from, don't want to view infrastructure strictly as a commodity, but people feel the value from the applications that they use. And so when you're further down that stack, the things you need to do is to deliver better, faster, easier to consume capability for those applications than the SLAs and the expectations of those applications in order to deliver a quality experience.
And Quinn, I know you've been thinking a little bit about what those applications are and how that looks on the edge. Do you want to tell us a little bit about that?
Yeah, sure. So as Qualcomm, we're developing the wireless technology as well as processing technology to enable a world of connected phones and connected devices, including IoT, automotive, and other things. So one of the things we've been working on is enable the connected enterprise. So both in the form of, if you have a laptop that's connected by Wi-Fi, you could be a 5G enabled laptop would be able to allow you to travel anywhere, even in places where you don't have Wi-Fi connection. So as long as you're covered under a cellular network, anywhere you go, let's say after you get off an airplane, everything will be all uploaded as soon as you have a cellular connectivity, right? So really enables the remote workforce or people travel a lot. So that's one in terms of connected enterprise use case. The other we're seeing is most of us here probably all have 5G phones today already, and some of them may have even 5G broadband access to the home, right? But in enterprises or in manufacturing settings where the Wi-Fi connectivity may not be the best, so there's this concept of a private network. Essentially, you set up a private cellular-based network, could be 4G or 5G, that are able to connect to your robots, to sensors in your manufacturing floors, to other things in the manufacturing settings. Be able to provide very, very high performance, as well as very low latency, very secure network. To be able to connect various things in an enterprise or a factory, be able to provide very, very reliable communication and very, very secure in a secure fashion. So those are some of the, I would say, use cases in enterprises and in manufacturing settings.
And as you're talking about that, I think, Kevin, you might have a couple of live examples of that.
Absolutely. Just to build upon that, I mean, the key kind of connection is the key element here, right? So I think Kevin said it great in his keynote, unbroken, right? So how do we reach that, right? In today's world, especially in manufacturing and in some of the specialized manufacturing areas of aero and defense, is how do we maintain or how do we achieve connectivity? And with the PLTE kind of capabilities and being able to have a hybrid environment, we're actually able to have connectivity in places we haven't had before, right? Lighting up a 3-mile range of a manufacturing facility, or getting inside of an airplane where our engineers are actually starting to build that they can't communicate today, right? And so having that capability with PLTE really helps streamline the manufacturing process as well, but more importantly, gets data to where the data needs to be consumed at the time that it's needed.
And you use the phrase there, PLTE.
What's that?
You used an acronym there, PLTE.
Oh, the private LTE, right. So that's the private network side of that, the cellular side of the equation, right? And because it is so mobile, you can literally drive trucks into an area, you can do a triangulation and turn that stuff on and have an immediate test set, right? Unfortunately, in today's world, you need physical SIMs. That's changing. As soon as that eSIM technology comes out, it's going to become even more productive, much more easier to consume, and easy for the end users to be able to tell, where are my employees, why is it taking them 2 hours to get into a site versus 20 minutes to get out of the site, what is the productivity gains, all the way over into the safety side of the equation, right? Looking at things like you don't want welders with the painters in the same region doing that kind of work at the same time, right? So there's all kind of applications as you start to spread over into healthcare and all those kinds of applications as well.
And are you guys literally building those?
Yeah, we actually deploy those today. We've actually been able to, again, drawing on some of the things that Kevin said, look at the supply chain of that, right? How do we turn an 8-month process now into an 8-week, right? We've been able to figure that out, right? So we've been able to get ahead of the supply chain. We've been able to drive it down into something that's very quickly and easily deployed, and then simply consumed, right? And so as we start to move more faster and faster down that supply chain route, it gets even better and better.
Fabulous. Sharon, just coming back to you on that. I know that you're implementing some of those yourself.
Well, we're a supplier of a technology called the RIC, which is the Radio Intelligence Controller. And this is allowing service providers, the ones who are building these private clouds, to bring that connectivity closer to where some of the compute might need to be. So, you know, we talked about prepping for this. You know, where do you deploy your workloads, right? And do you do them on-prem? Do you do cloud, public cloud? And now the telcos, they're building these much more scalable mesh networks, and that both provide more control over the security than the ring, but also much more scalability, because the volume of the devices is scaling exponentially. And so you need to be able to construct and architect the network in a different way in order to provide that performance that the 5G range allows. And so that software sits at the middle of those clouds so that they can control and slice and dice that bandwidth as appropriate.
And before I come off you, I want to also push you a little bit, because you've teased the framework sometimes about how you decide where you put a load.
Yeah, so we think about commitment and control, right? If you think of your kind of 2x2 axis. And you know, on the one side is, how long does that workload need to or is likely to persist, right? So that's your level of commitment. And the shorter the time frame, the more likely you are to put it into a cloud where you can spin something up and down very easily and very quickly through automation. You're not going to wait through purchasing cycles and the time it takes to rack and stack gear. So that's that one commitment access. The other is control. So, you know, what is your perceived control of how close that workload perhaps needs to be to data, security considerations, although I say that that's often a red herring, because you can secure things, it's just you do it differently in the two different places. But then also, sometimes there's certain specialized workloads like genomic computing or high performance computing clusters, like when we're designing chips, and literally the chip of the processor that's in the compute unit might change the performance of that workload in a very different way. So when you put something in public cloud, you might not have the understanding of whether or not that specific chip and that specific firmware is running. So you might need that control, in which case you might keep it closer to you or more in your control to do that. So that's the framework which we use. And then as a CIO, that's just where you put the workload in the cloud. I think of it as even going further. So if something's available that's SaaS, for my industry, I want to deploy that first. Then if I can't get a SaaS product, can I get a cloud native deployable product? And we work our way kind of down and back towards, oh my gosh, I have to actually rack and stack this gear and do all this work myself.
That's really nice instruction. I really appreciate that.
Sure.
And I appreciate that one extra step, like, because that was a lot about on-prem versus the cloud. You know, Quinn, do you have any suggestions for how you would extend it to that next step of, you know, to the edge versus centralized, whether it's on cloud or on-prem?
Yeah, so maybe just to give some examples of maybe specific use cases, like if you think about supply chain, warehouse automation, that's one example of a lot of things maybe traditionally is done by manual labor force. Now it's, previous panel talks about robots. So a lot of things could be automated by robots and other things. And the robots obviously needs connectivity to the network. At the same time, also needs intelligence locally on the robots, so it knows how to navigate the warehouse and be able to collect enough data and be able to communicate to the central system, right? So a lot of the compute, some will happen in the cloud, some will happen on the devices. So we believe in a world where some of the compute will happen in the cloud. The really heavy, I would say, compute intensive load will probably still happen in the cloud. But some of the computation, even including AI processing, which were very, very low latency that's required. And sometimes you also need a secure environment, maybe not transfer everything to the cloud. There's a bandwidth cost also. So a lot of these will happen in local devices. I mean, another example, less in the enterprise would be like autonomous car, right? The autonomous driving system is an AI system, if you think about it, right? You can't react to traffic light, moving objects by sending everything to the cloud, get the processing back and tell you what to do, or tell the car what to do, right? The intelligence actually needs to happen real time in the vehicle itself. So that's an example of things, some things just happens on the edge of the network, edge broadly defined, some will happen in the cloud.
And to use your example then in the autonomous car, but the map design, for example, the 3D modeling and all that might come centrally, and then so you might share the model, but then it gets used and reacted to.
Yeah, absolutely. I think the training itself, which is more computational intensive, will probably happen in the cloud. But then the inferencing model, exactly what you do when a car sees a red light or people walk across a dog on the street, that's going to happen locally in the car.
Right. That's fabulous.
Right, because you don't have to deliver all the data you trained it on to that device,
That's
so
right.
it makes
That's
it
right.
much more.
That's right. Yeah, and then you need the high-speed reaction time, right?
Exactly.
You can't wait until everything goes in the cloud and come back.
So maybe there's a new axis that's latency.
Yeah,
exactly.
It becomes a-
And that's what the 5G networks enables.
And Kevin, how does this overlap into what you guys are actually implementing in some of these industrial sites?
Well, I think the real-time nature of getting into facilities, especially in some of the specialized manufacturing, being able to penetrate areas that we couldn't before, especially in applications of welding, right? You're putting a person in a very precarious situation to be able, or even dangerous situation, to do some welding for the manufacturing process. Now you can use a robot because now I can connect to it, right? So using this, different technologies, whether it's wideband or whether it's much more focused to penetrate through the halls of airplanes or different facilities around within the manufacturing plant is really important.
You've teased that airplane word a couple times. Can we hear it in a bit of detail?
I'm going to hesitate on naming the stealth vehicles that it's capable of penetrating, but let's just say that it's capable of even facilitating communications within those applications as well.
Okay.
Really handy in mining, really handy in construction, building big buildings. The really cool thing that I like about it is because it's private, there's no backhaul to Verizon, there's no backhaul to AT&T, right? You own it, it's coming to your network.
Right.
Right? So the data is secure within your network itself. What you do with it is up to you. How you apply machine learning or additional AI to that equation is a value add, right? And because it is unbroken connectivity, it becomes real time.
Okay. And when you talk about that security, I guess, yeah, in a private 5G, that's quite quite nicely
Right.
contained within the broad. Go ahead.
Well, we see so much of it nowadays. I mean, AT&T and Verizon, they light up football stadiums. Now that football stadium can do it themselves if they really want it.
Right, okay.
Right? So, I mean, we're not talking hundreds of feet, we're talking miles, right? Replacing 400 or 500 laps with 10 radios to be able to go from 60% coverage to 100% coverage is extremely important, extremely valuable. Cutting the cost on that, right? So the average implementation on that on a 3-year plan with support is less than $2 million to stand up, right? So it's easy to step into. Serviceability of a lab, well, I need to cycle those every 6 or 7 years and replace. The wireless and those radios, it's like every 35 years.
Wow.
Right? So now I'm not sending people into the field so much anymore, right? So again, talking back to the business outcomes, it starts talking to the cost savings at the business level, revenue generation and opportunities, and then the ecosystem that can wrap around that. It's huge.
So it's better coverage, fewer devices because they have a bigger radius,
You got it.
and longer mean time between failures.
Yep.
Yeah, it sounds like a killer business case. In some
It
ways.
is. I mean, it's very simple to justify. The nice thing is Quinn brought up the robots within the facilities. We have clients that do that today in the oil industry because they have the robot dogs that are running around doing security. Now they can connect and it's real time and they can actually react, and now I can apply machine learning to say, I need you to do now because you've solved, right? And those things can be shutting off valves, turning on valves, changing access points, maybe shuttling people into a safe region because something has happened in the plant itself.
Right, so geofencing.
Right.
And are you seeing, I mean, obviously phones are ready for this, tablets are ready for this. When you're talking about the robot dogs or cameras and things like that, are you seeing them available with these radios? Or
Absolutely.
is this retro?
Absolutely. So it's just a connectivity to whatever the robot device is going to be, right? So is it Wi-Fi? Is it cellular? It's probably both, right? It's certainly not wired, right? Unless it's a highly specific application like in a hospital or something like that, right? Or you need to get it into a range to where you should have cellular connectivity, right? And so we can beam those things around. We do these things on the borders, and you know when you cross this line, it doesn't work here, but it works here, right? So it's very focused and very manageable.
Very directional, it sounds like.
Very directional, absolutely.
Are there, and that begs the question, are there licensing issues? You know, when you talk about the football stadium and all of a sudden now you're doing 2 or 3 mile, you know, are we requiring special SEC permits and so forth?
No, it's your private LTE, right? It's there for you to be able to purchase and you own it. That's the nice thing about it. When you don't have to backhaul or license AT&T and Verizon, you don't incur that uptick on the connectivity and the services they provide on top of that, right? So it makes it, again, it's just an easy business case to apply.
Yeah, just to add one comment to your question about spectrum.
Yeah.
So the private network typically runs on this spectrum called CBRS, which is an unlicensed spectrum.
Okay.
That as long as both sides, the network and device, are enabled to operate in that network, then you can use it without having to get a special license from the
Got it,
operator.
okay. Thank you, that clarifies that. Yeah, because I'm old enough to remember the Spectrum auctions.
Yeah.
You wait, all of a sudden we get some. So we're talking about security. I think Sharon, you had some interesting thoughts on, you know, essentially SASE, what you're doing in the enterprise there for that.
So first, let's just talk about what SASE is. It's the convergence of SD-WAN and a full security stack, usually in the cloud, so you can consistently manage your security policies throughout your network. And also has an understanding of the identity of the person who, or the device, may not be a person, who is accessing resources on that network. So zero trust is often, even though they're not, zero trust is a part of SASE, it's not SASE. You often hear those things coming in the same breath or used sometimes synonymously, when SASE I think is a much more of an umbrella set of solutions. Look, you see this happening. I'm not the CISO, but I do have the budget for all the tools the CISO buys. And I also manage all the teams who try to deploy those tools without getting in the way of the productivity of the workers, right? And this world, at some level, has to converge so that you don't have 6 different tools fighting over the network on whatever device it is that's communicating and connecting.
Right.
But you also need, again, it goes back to business outcomes, speed of deployment and consistency, and to be able to control that across, well, there may be smaller devices to set up the 5G network. That's to enable the number of devices this gentleman would like us to all have in our hands. And you need to be able to drive that policy and change it without having to talk individually to each one of those devices. So this centralization into the cloud and the convergence of the stack is sort of a natural way to go. Now, every security player comes from a different part of that stack, and so I think we're going to see some really interesting solutions there. I also think you're going to see a lot of AI applied to some of the decisioning, and again, making that easier for the security professional to manage and make fewer mistakes and leave fewer holes open.
Right. As we move from humans doing it to machines doing it, right?
Yeah.
It's like a top theme.
Yeah.
And in doing that, I guess it seems like a big enterprise to be changing over your network to be SD-WAN and to be, completely
So,
specified.
well, that's what we see in our business. A cloud-controlled, collecting lots of telemetry in order to drive, again, consistent configuration, to be able to correct configuration if somebody out at the edge does something you didn't want them to do, whether that's your person, because sometimes it's your people who do those things, or someone else that you didn't want there doing it. We have a little bit of a unique approach to SD-WAN, so we operate at a different level of the stack. So we have a tunnelless architecture, so that drives a lot of cost out of the equation. We just deployed it in-house and took 50% of our telco cost out of the mix through that. But again, I think the key is that it's cloud driven and it has AI embedded in it for any of the things that a machine can make the decision on without a human in the loop. It has an interface to notify you that you need a human in the loop, because sometimes you do. And really minimizing your team's focus to something that's very complex and very unusual that isn't standard, because everybody does deploy these things a little bit differently, and we create problems, or I as an enterprise are talking to this particular cloud provider and they've engineered something different, so we have to find out what our problem is together. But that's where I see the world going.
And then having kind of that cloud central control and having the AI layer on it, it makes it easy to do, right?
And it makes me take my staff and again focus them towards the things where my end users really feel the value.
Right.
Automate what you can. Let machines do what machines are good at. And in networks, the volume of data that we have to wade through to solve complex problems, it's not what humans are good at. So the more you can have the machine do that, the more you can be delivering those value-added services as an enterprise IT leader.
As you can by that. Yeah, no, that's amazing. Okay. And any tips and tricks for people who are trying to look for this themselves or trying to roll it out themselves?
It's all very new, so I still think, if you hear me talk, many things go, and we've heard it in some other sessions, what's the quality of the data you're feeding into the system? So when you start trying to create microsegments between your end user and policies and who should be doing what, like how good is the data that you have about the roles and permissions and who should be accessing what? I think for so long, we've used access to the network as a proxy and HR department roles and responsibilities as a proxy for who should. I think that that's where we're going to find we have a lot of work to do. The technology to make the decisions, if that's all right, I think it exists, and I don't think it's that hard. But I think it's always about what's the data that you're feeding into it. Can you get people to agree on that policy and that that's the right way and the way you want to operate. It's usually about other things, not necessarily the core technology that you're deploying.
Right. And maybe that's a bit of a hook, because when you talk about that, it immediately reminds me of all of the Active Directories that everybody has that are full of garbage, and the millions we've spent trying to clean them up and restructure them and do them again.
What does your CMDB look like? Is it any good? Do you
Odds are
understand?
no.
Right?
Unless you're using it for DevOps, and unless you're really
right.
betting on it, right?
Right. But for a lot of enterprises, I think because we've relied on people to do these things, getting to that automation is difficult if our data quality isn't what we need it to be.
And is that then an opportunity for you guys?
Oh, it is. I mean, the real-time nature of the data is wonderful. And I think if you look at the examples of the self-driving car, I mean, Elon has said that Tesla will always make the right decision, but the data integrity has to be there as well to be able to make that proper decision. And if that decision needs to be made in real time, how do we adjust the algorithms to say, hey, I got bad data, right? How does it adjust itself, and how does it put in the boundaries of saying, I think that's a bad decision in this situation, right? So situation awareness comes into that play, and so the algorithm now gets much more complex.
Yeah, okay. And I guess that in a way suggests it could be self-correcting someday.
Well,
but definitely not today, and definitely not at the beginning, right?
Yeah, so we're just scratching the surface of it, right? So it is new. Really starting to see the real-time applications of we start to learn what are those variables that come into this equation. And it goes beyond just the connectivity. It's because of the connectivity that we couldn't get there before. And as soon as we solve those next problems, then the next one's going to be, and then we can build on it, and it gets better and better.
So to build that data. And Quinn, maybe that plays into you a little bit, really thinking about your day job, looking over all the startups that Qualcomm Ventures invests in. What do you see coming, down the pipe that you can tell us about?
Yeah, so we broadly invest in, I would say, in front of it, on top of our value chain, companies that can leverage the technology we're building, whether it's connectivity or processor technology. So one area we've been spending time on is applied AI, right? So with this proliferation of ChatGPT, there's just so many companies that's building all sorts of things that's in this realm of generative AI. Now, some are building, I would say, foundational model plays, maybe very specific, targeted at a particular use case. So you'll see emergence of some of those companies, maybe not as big models as ChatGPT, because ChatGPT is like 175 billion parameters or something like that. You'll have to see smaller model, companies building smaller models, but maybe targeted at specific use cases. And then also for enterprises, you have sensitive data or proprietary data. You don't want to send everything to ChatGPT, right? That gets used by other people, and you don't know where that information goes, right? So for enterprises, if you want to have your own instance of a ChatGPT, maybe just for enterprise use cases, right? Be able to allow even IT to ask questions about what we do in certain things. You want to have your own instance of sort of ChatGPT, but maybe for a narrower use case.
Right.
So we see companies developing models, specific targeted for specific use cases. Then we also see companies that, just building specific, I would say, applications, but leveraging the ChatGPT API. So the back end, they're calling ChatGPT, but at front end, they're building very specific use cases to solve very specific problems.
Which then becomes almost like an app on top of ChatGPT.
Exactly. So in the mobile world, you have all these mobile apps, right? That you can download on Android or iOS. In the world of AI, I think you're going to have a proliferation of AI applications that you can just kind of download equivalently to a mobile app that various people can download and use. Yeah, so I think there's a lot of interest in this whole area. I think ChatGPT or generative AI have some fundamental disruptions. I think it's still early days. I think we see a lot of, certainly we have to be careful how we use it. There's hallucination problems, there's all kinds of other issues. But if you use it properly, I think there's a lot of productivity gains you can have, a lot of interesting use cases you can do. So a lot of startups come up with all kinds of creative solutions to leverage that whole generative AI.
It's a great place to think. And actually, I think I know, Sharon, that you've been thinking about a risk framework around that. you've been dealing with risk?
Yeah, so, and I think the risk framework's going to evolve almost daily because you're already seeing, right, Microsoft had Copilot in their Azure product, and while there's some things going on, they make some specific promises about protecting your data. OpenAI was explicitly not doing that. Like just last week, it changed, but as we've been looking at this in-house, I wish I had the slide, it would be fun to show. We created a framework of kind of how public is the data that you're feeding it, and then there's another axis, and it helps you decide, I think it's who are you sharing the response with, or how are you using the response, and is that in a more internal or external environment? And then we've broken out, okay, you know, if you're creating an email, where does that fall on the axis, and how do you think about whether or not to use ChatGPT for that, both based on the input and how the output's going to be used. And I just think the lines on where you stop are going to continue to evolve as each technology player building these LLMs come out and make different commitments, or how, to your point, you're able to configure it for your use internally versus using, it's sort of like a public cloud, private cloud debate. Again, right? But I get a newsletter called The Neuron that like literally every day has 5 new companies that have sprung up and new tools that are out there to think about this. And then we ourselves are thinking about, okay, we on our AI-enabled network products, we have a chatbot called Marvis. Do we continue to invest in that? Does it make sense for us, or do we leverage another technology and take those resources and put them to continuing to apply the different, not the LLM models, but the different kind of machine learning models we use to decision in the network further into the stack, right? So I think literally when somebody earlier today said he hasn't felt this much energy since kind of the internet became a thing, and there's a woman at Google, Cassie Korsakoff, who wrote, you know, hey, this AI stuff's existed for a long time. It just didn't have a user interface that was accessible to all of us. And ChatGPT brought us that UI. That's kind of like the browser brought us that. And it very much feels like that time. And I think we're all going to have to figure out, given our niches and our specialties, how we're going to apply and leverage that technology. And it's not going to be good to solve every problem. Like I said, the kind of AI we've been using in machine learning algorithms, the much more statistical machine learning, we find that very good with the right data targeted at the right problem.
Right. This is, you can use a really narrow AI as opposed to a more broad one. When you look at your model, which I really appreciate that framework of, you know, how public is the data you're feeding it and how important is what it's giving back to you or where you're going to share it. How do you enforce it then? Does it become an education problem? You try to teach people, or
well, so we've internally developed a policy. We very much believe that, first of all, you hire a lot of people because they're smart and they're talented.
Right.
So we feel like it's education and communication. We're not going to get it right perfectly, but we're not of the ilk as a company that calls the employees Junivators, that we're going to turn it off at the door. Now, through CASB and some of our other technologies, we can see that we have in place in the network. We can understand a little bit about what's being shared, and if we see something nervous, that makes us nervous, we'll go talk to the people. So we've started monitoring for what is going in and out to ChatGPT. And so far, we haven't felt the need to shut it down, but again, these things evolve and change on a daily basis. So I think stay tuned. It'll be really interesting, you know, to come back here next year and see, you know, what part of all this discussion was hype, fear, and unwarranted. But I think we'll need that perspective of a year to do that.
Or blue sky optimism, right? But at the moment, it feels like there's a lot there. So speaking of smart and talented, Kevin, how are you using ChatGPT? Are you guys involved in that yet, or no? Is it writing your proposals?
For writing our proposals? No, I think for getting information in those proposals, right? for those of us that may have issues with a blank sheet of paper, it accelerates the process, right? It gives you an idea, it gives you a thought. It can give you direction. It can also give you misdirection, right? So I think it's a tool to be used wisely at the moment, because I think the session before this talked the difference between AI and ML, to where I don't think it's quite making decisions for us yet, but it can give us patterns, it can give us predictions, and we still have to interpret that, so, and use it wisely.
Okay. And Quinn, would you like a last word on that before we wrap up?
Well, last word. I think previous panel mentioned it was like with a spicy sauce. That was, I think I agree with that. I think there's going to be a lot of development in the next year or so, to your point. A year from now we come back. The other thing I would say is, I think a lot of the stuff is still all happening in the cloud today, but we have actually showed a demo where a $1 billion parameter model, you can run it on a mobile device, a stable diffusion model. So there's things you can do already on these edge devices, as simple or maybe as just on the smartphone, that almost has similar performance as what you can do in the cloud. So a lot of innovation is going to happen both in the network, in the cloud, as well as on edge devices.
And suddenly it's AI in your pocket, right?
Yeah.
That's wonderful. All right, well, thank you very much, guys. I really appreciated the expertise on this, and it was a terrific conversation.
Thank you.
We'll give it up for the panel.